అందరికీ నమస్కారములు. నమో నమః. శ్రీ గురుభ్యో నమః. శ్రీ మహాగణాధిపతయే నమః. Today is another good day for all of us. Today is the 5th day of our classes on Vedic mathematics by Gautham Mukherjee garu, and we will start the session with Vande Mataram and chanting of Prarthana. I request Chala Chittibabu garu to recite Vande Mataram, please.
Vande Mataram, Vande Mataram, Sujalam Sufalam, Malaya Jasitalam, Sasyashyamalam Mataram, Vande Mataram, Subrajosna Pulakitayamini, Pullakusumita Drumadala Shobhini, Suhasini, Sumadhura Bhashini, Sukhadam Varadam Mataram, Vande Mataram, Vande Mataram.
Vande Mataram. ధన్యవాదములు చలా చిట్టిబాబు గారు. Now going forward, let us request Surya Prakash garu to chant Prarthana, please.
Sir, namaste sir. Sarvebhyah namaskaraha. First, let us have 1 minute jhanam. Let us observe 1 minute jhanam. Don't let your manas goes to elsewhere. Concentrate on your breathing. Give auto suggestion to your mind that not to go elsewhere during the class. Let us chant Omkaram 3 times. Om Ganana Antva Ganapadigam Havamahe Kavim Kavinamupavasravasamam Jyeshtarajam Brahmanam Brahmanaspata Anaspunnannoti Visidhasadanam. Om Sri Mahaganadhipataye Namaha. Matrudevo Bhava, Pitrudevo Bhava, Acharya Devo Bhava, Atidhi Devo Bhava. Om Prano Devi Saraswati Vajebirvajinivati Deenam Avitriyavatu. Om Sri Mahasaraswatyai Namaha. Gurureva gati gurumeva bhaje gurunaiva sahasmi namo gurave na guru paramam sishurasmi guru matirasti guru mama pahi guru Jnananandamayam devam nirmalam svatika kritim Adharam sarva vidyanam hayagrivam upasmahe Shruti smruti purananam alayam karunalayam Namami bhagavat pada Sankaram loka sankaram Sankaram Sankaracharyam Kesavam Badarayanam Sutrabhasya Kruto Vande Bhagavanto Punah Punaha Isvaro Gururatmeti Murti Veda Vibhagine Vyoma Vajapta Dehaya Dakshinamurtaye Namaha Om Sahana Vavatu Sahano Bhunaktu Sahaviryam Karavavahai तेजस्विनामधीतमस्तु मा विद्विषावहै ओम शांति 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 धन्यवादं सर सर्वेभ्यः नमस्कारः ओम श्री गुरुभ्यो नमः हरि ओम श्री गुरुभ्यो नमः
ధన్యవాదములండి సూర్యప్రకాష్ గారు.
थैंक यू सर नमस्ते सर
Now let us request Gautham ji to continue the webinar, please.
सभी को नमस्कार। So yesterday we were here and maybe that we can give, we can discuss about more examples of the same. Yesterday we went through this particular example. Now, as you are telling that suppose you are given a square root for 552049. Steps are group digits of 2 from right. Then square root of 55 gives 7. So 7 and remaining is and remaining is 6. Oh, sorry. When I click this, it goes away. Acha. Remaining is 6. And what happens? The double of that, 14, we keep it there, keep on the left. Double of that, we keep on left. So here, when we make square root of 55, we get 7. And the remaining is 6. And double of 7 in the 14, we keep left. This 6 with 2, it goes to 62. Okay, it's clear? Now 62 we divide by 14 to give 4 as we put down here, 4 as a quotient and 6 as remainder. 14 into 4 is 56 plus 6 is 60. 6 as remainder. This gives 60. From this 60, we subtract square of this. Square of this. So we get 44. 44 when you divide by 4, it gives 3 as a quotient and 2 as a remainder. These two getting with that 1, 2, 3, 4, fifth digit of my number, which was is supposed to be square rooted. This makes it 24. From this 24, we subtract 2 into 4 into 3, so it becomes 24 0, and then 0 we put down, and then with 0 9 it gives this, and final thing is that square of 3 is to be subtracted to confirm that in this case it is final 0. So it is 743 0. Actually, the explanation of all these things, similar one example more is given here. One more example is here. Now, explanation of this is like this. This is suppose a 3 digits number is squared. Yesterday we discussed this. So a square x to the power 4 b square x square plus c square plus this 2abx cube, 2acx square, 2bcx, so cross multiplication between terms. So finally group into this powers of x. Now, as you remember, first we have to know what is a. And suppose x is the or 10. To 10 to the power 4, 10,000 place, then it is this place. So this is given to us. This is the number we are giving square root. So turn by turn we have to find out what is this a. So we first square root it. So it gives a as integer. Then we subtracted twice of that a, we divided. This quotient gives me b, so this b. So likewise, after b, we subtracted, remember, subtracted the square of the second digit. So it gave to this number, from where we again divide by 2a, see 2a. So therefore, the 2a, 14 in that case, we kept to us left because we have to do it twice here. So we got that third number, and after getting the third number, sorry, when we subtracted the twice of these two numbers, we got 0. And finally, something still at the last number, again is subtracted square of that number, and we got 0. But if we do not get 0, that means there will be decimal points. Now, in the same line, suppose we have given a bigger number, where this 10 to the power 6 means 10 lakhs is also there. I have some. So it will be, the square root will be of 4 digits. Now, how it comes? Where the procedure will be extended. First, you have to do again this number and so on. I was doing an example. Suppose we should I evaluate it? Higher digit number. Let us do it, no?
Yeah, go ahead.
Suppose you are given. Somebody kindly note down this. This one. This one. A square x to the power 6 plus this last one. You can note down only the last line. Don't have to note down it. A square x to the power 6 plus 2ab x to the power 5 plus b square plus 2ac x to the power 4 plus 2bc plus ad, like this way, this is written, 2bc plus ad x cube plus c square plus 2bd x x square plus 2cdx plus d square. This much. Okay, should I proceed?
Yeah, go ahead.
Now, my given number is, for example, 6990 6321. This big. Likewise, we did earlier, because the square root of this is 8 and remaining is 5. Double of this we keep because we have to work with this twice. In this case, thrice, because there is one AB is there, 2 AB is there, then again 2 AC is there, and then 2 AD will be there. Now, this makes it 59. So this is my AB term. This 2AB x to the power 5. This AB actually will give me B. If we divide it with 16, I mean twice A, this it will give me B. So it is 3. And what is remainder? 11, isn't it? (16 into 3 is 48, and 59 minus 48 is 11. Okay, 59 minus 48 is 11. So it becomes 110. From this 110, we subtract. What to subtract?
15.
We subtract B square. See, the term is there, B square. So if we subtract the term, we get 2AC. So we subtract the 3 square. That means it becomes 101. 101. This will give me, when we divide by this 2A, we get C. So 101 divided by 16 is how much? 101 16 by divided by 16 is how much? It becomes
6.
Gives 6. And remainder is 101. 101 dividing by 16. So
10.
101
Okay,
dividing by
101,
16.
okay. 1
It is
is 5.
5. Now we get 56. From this 56, you go to the next term, you see that we have 2 terms called 2 into BC plus AD. You have seen? 2 have to BC plus AD. AD is unknown to us, and BC is in front of us. BC are in front of us. What is B? What is C? B is 3. This is A. This is B. This is C. And I am going to find D here. So 2 BC is 3 into 6. So from the 56, we subtract BC, twice BC. 2 into, now this roll of 16 is not there because 2 BC, 2 into 3 into 6.
46, 20.
So it becomes 20. Now, this will give me, 20 will give me this, when you divide it by 2A, which is 2A is already stored there, 2A we have kept there, it will give me D. So 20 divided by 16 is 1. Okay. And remainder is 4. $43. Now we got for 43. We have got 43. But from this 43, what is the next term? What you have to do? This 43 actually is a mixture of two things. I mean, not 43. This from this one, there is actually two terms is mixed here somewhere. One is C square. You see next term, because we went up to, so far we went up to 20 divided by 16, which gives me 1. So that was the we get, and that gave me D from twice AD. Then this 43 is a mixture of C square and 2BD. So C square is how much? 6. So 43 minus 6 is 7.
$37.
7. 36.
Sorry,
No, 43 minus 36.
36. Oh,
Isn't
sorry,
it?
30. Yes. 36 and 7. Seven.
Now we have 72.
7. Achha, now this 7, when we subtract again we subtract this one. 6 we subtract. This from here. So we'll see that one more 1 comes somewhere, and we'll get 0. This comes is equal to 1. This 1 comes here and 0 comes here.
Six into 1, isn't it?
Huh?
8, 3, 6, 1. 6 into 1 is 6, 1.
Huh.
6. 7 minus 6 is 1. We earlier multiplied 3 into 6, 18.
No, 3 into 6. Actually, here 1 digit, although it is correct, but somewhere you know that actually that somehow it will come, and again finally this 1 square twice CD, because the 6 square plus BD was done. We get this number up to that AD. Now after that, this C square BD and so on, and 2 CD and D square, it matches, and then it comes to 0. It's a bit lengthy actually.
Okay.
So all these things, and finally it also this gives 0. Finally it matches actually.
Okay then.
So you got it that how up to the last digit we found out that from 2i's AD, from the expression. Basically, did you note down this?
Yeah.
So this one actually, this thing actually turn by turn we have to evaluate this. Then this. Now come back to a smaller number, say this one. We did this one. We did.
Yeah, we did this.
55 2049. But this
Yeah, it was done.
this was also done.
No, this was not done.
This was not done. So 668 680625. Let us do this. Now, anybody else except Babuji, please tell whether you are following it properly.
Students are supposed to respond. Somebody has to volunteer and come. If you have not understood, ask so that the doubt is clarified.
Yeah. You note down here. I'll tell you. You note down, then you note down this. You note down this line. Please note down this line.
Actually, in this expression, the square of an expression ax cubed plus bx squared plus cx plus d. I think you forgot to mention whole square. Something missing?
Which one?
You wanted us to note down, isn't it? The square of an expression ax cubed plus bx squared plus cx plus d whole squared is to be written.
No, square of an expression. So already it is
The square. Okay. Square of an expression. Right.
For 3 terms, it becomes total 6 terms.
Yeah.
But so 3 for squaring and 3C2. 2 at a time, taking 2 at a time. But here it is, in case of 4 terms, it becomes 4. Square of these things 4 correspondingly, and 4C2 is 6 terms. So 6 plus 4 total 10 terms.
Okay, we'll go to the practical example.
Good English. So you noted down this line, a square x to the 4, everyone. Sorry. Now we come to example. I was doing 66, what was that? 680625. So what we do here? First, have to find out A. So A square is mixed here. So I have to do square root of this. What is that? What to do that? Please tell.
First is 8.
8. Now, Babuji, let others tell also.
No one is talking, so I had to come in.
Yes.
Otherwise, it is total silence.
Yeah. So what makes you not, please open up, what now? Are they giving the permission of talking when in non-silence?
Oh, okay, I think, just a minute. How to do that? If anybody wants to talk, please raise your hand so that I can unmute yourself. Please raise your hand so that I can unmute yours. And you can, one person can talk at least. Who wants to talk? Or is unable to talk? Why nobody is talking? All are muted, okay.
All are muted.
Okay. At least you raise your hand so that I can unmute yourself. If everybody starts talking, it becomes a noise. Who wants to talk? Please, at least one person say, I want to talk. I can unmute. Don't worry if you are not able to follow. I want.
This is
Yeah.
This is the training program.
Lalita Rao. Okay, I'll AVN.
A general participant must say that what is the difficulty being faced.
Right.
Sir, here I would like to say something, sir, because see, at the time we were studying up to 10th class, there was general maths and composite maths. We are of general maths category. So these algebraic expressions, they are Herculean task for us to solve. That is the reason we are unable to talk. That otherwise we are ready to participate actively.
See, Prakash Rao Garu, try to
Yes,
understand this expression which Gautamji has said is there for understanding what is being done. If you are not able to follow, skip it and understand how the work is being done. Okay, for people who can understand, this is the explanation of what is being done. So people who are able to follow, let them follow it. People who are not able to follow the work being done, example being done. So, okay. Now,
okay,
Lalita Garu, you can.
We will not go for 4 digits. I will be confined to 3 digits.
Right.
Because everybody may not understand the algebra behind this.
Right. Lalita Garu, you can now talk. AV and Lalita Garu.
Okay, Nandi.
Right.
The 8 8 is 64.
Yeah. And then what should I write there?
Then 68 minus 64, we will get 4. And drop down 0 from the top. It becomes 40. And double the 8, it will become 16.
16, yes.
So 16 into 2 is 32.
Yeah.
We'll get the remainder 8.
16 into 2 is 32. So we drop it down. It becomes my second digit.
Again, you drop down 6 from the top level and it becomes 86.
Exactly. Not drop down, you use as a unit digit and 10 digit. So it is 86.
86. So here I get some confusion whether to 2 into 8 like that we have to do, or just square this one 2 into 2 4. We have to again minus, no? We have to subtract from this 86.
Yes. Here you have to subtract
from 86.
subtract 2 into 2.
2 into 2. Yeah. So you have to 2 into 2 means 4. You will get 82.
Then this what to do? 82 what we do?
5 again.
So 5 we drop down here.
80.
Then
We get 2. And again drop down 2 from the top. 22 it becomes. Again 1. 16.
no, here it is not. Here
Yeah. We have to subtract it again. Yeah, correct.
this double of that.
Double of that. Yeah, correct.
So this gives me 2.
20. 22. You will get 2.
2.
Again, you drop down 5 from the top. 25 it becomes.
Yeah.
Again, one.
It becomes enough. First you say that 2, when you 2 divide by 16, we get 0 here.
No, I didn't understand, sir.
These two you can actually, these are 2 BC. 2 BCX. So here you, no, not 16. It is you have to subtract by something, 2 into 2 actually. You are dropping it 2 into 2 so that it becomes 0 and remaining is 2. This 2 is this remaining 2, 22 minus 20 is 2. This 2 is divided by 2, divided by 2 BC. Anyway, this gets this 0 as quotient and 2 as remainder, this 25. Now again, this with the 25, what you
16.
do? 25 minus
16.
Now, this square of this. Square of 5. So 5 into 5. Earlier we did 2 into 2. Because see here 8 into 8 is already taken care of here. Here we use 2 into 2, this 2 one. But what is the 5 into 5? 5 into 5 is the last step. 5 into 5. This gives me 0. So signifies that it was a perfect square. There was no decimal point here. Had there been decimal point, it becomes more complicated. There are many other terms will be there.
Here I didn't understand, sir. In the last example also, I didn't understand.
Last one. See, this is the square of that 3 things, no?
Yeah.
Square of these 3 digits. So 8 square is we have already taken care of, 8 square.
Okay.
2 square we have used here.
Yes.
But what is the 5 square? 5 square is the last step. See, this 25 we got, from these 2 we got 25. We have to match that it is, this is, we have to subtract this square of this 25 becomes 25, it becomes 0. 25 minus 25.
Then we have to see that it should become 0 then?
Unless it becomes 0, there will be some decimal points and so on. It will not be closed. Here it shows that it is a perfect square. 6680625 is a perfect square, and its square root is 825.
Okay, sir, got it. We have to practice it, or you can show us one more example also.
One more example. Let me find out one good square number. You can also find out the calculated good square number of 3 digits. 3 digit square. What do you do?
Yeah. Shall I tell one number, sir?
Yeah.
944
944
784. So 9
Hmm.
81
81
13 we, 13 we get.
and we write some in the on the left.
Yeah.
Left, what you write?
Then we got 13, no?
18 we have to write.
You have to write 18. 13, yes.
Yeah, this is 18. And we got 13. So we have to drop down 4 from the top. Isn't it? 134 it becomes.
Sorry. No.
Yeah, go ahead. Let's go.
Then
Yeah.
from 134, what to do?
18 6 7 7. 7
7.
126. So 8 we get remainder.
8 we get remainder. That 8 actually comes here.
Then again drop down 7 from the top. It becomes 87. Here you tell us one more time. From this point.
From this point?
Yeah, you tell us 2 into 7 into 9. We have to do it.
No, not that. Because 2 into 7 into 9 is already there. Here we use 2 into 7 into 9. That's 18 into 7 we use, no, 126. You remember?
Yeah. Over.
We already used. Here,
Yeah.
this is not used. 7 square.
7 square we have not used. Yeah, 7 into 7. Yeah. So 49.
49, how much?
38 we got.
What do you do there here?
38, 2, 18, 36. 2. Again, you drop down 8 from the top, it becomes 28. Then I got it. So 28 means 1.
So 3, 2 here. Huh?
Yeah. 28 is the remainder last. So again, subtract 18 from 28.
From
Correct, sir?
28.
10 we get.
Let me see here. Some problem comes sometimes. Some problem comes. I'll tell you. The procedure I'll tell you. Actually, what happens? This carry is they get also mixed up. The procedure.
It is a perfect square, and actually it is 972. Yeah, 972 into 972 is this much, 944, 784.
It is okay. See, 87 we did 7 into 7. That's fine, no?
Yeah. So 30 up to 38 it is okay, sir. Correct.
Gautamji, I mean, I don't know the rule, but then what fits in is you have 28 now. 28 minus, we have finished 9, 7 into 2 into 2.
87, 7 into 2 into 2.
That is 28. 28 minus 28 is 0.
Which one?
We have 28 as the remainder, isn't it?
Yes,
Now,
yes, yes.
so 28 minus
7 into 2
7
into
into
2.
2 into 2 is
Ah.
28.
Oh, yeah.
Yeah, correct.
Yes,
7
yes.
into 2 into 2.
But
And
how it
is-
happens, I
that,
don't know.
That we didn't use, yes.
But in the last example, we got 25 straight away. So we have seen that it should be 0 in the last. So we got 5
38
square.
become 2 into, yes. Now what?
But here we didn't get any square like that. Like 25 in the last example, we got 25, no? So you said it is 5 square is 25. We have to
Oh, no,
minus from-
No, one more step is there. Yes. So this, Babuji put it correctly. So this is 0 and we put here 0. 28 becomes 0, 0. Now this 4, what is the 4? Use of 4. This 4 is there, 0, 4, 4 is there. Still.
Yeah.
From
0,
that
4.
we subtract, we didn't use this one. This square is not used. 20
Yeah.
is equal to
Acha.
0. This finally we get another 0. 2 zeros we will get. 1 0 will come from this one. 1 0 will come from this 0, this one. And another 0 came from this 0.
Okay.
This was good. Somewhere I thought that it is something more than 28. Then you told me it is 28 only. Then I was thinking, had it been more than 20, it had happened sometimes. Suppose we find that this multiplying these two becomes more than something. So then you have to reduce one number, and then there are some procedures there. I was searching for that, but actually it is already 970. It is fine. So thank you. So detected that it is the procedure.
Acha.
One more. Somebody else may give also.
No, somebody was asking how you got 36.
Huh?
In the chat box, somebody was asking how you got 36.
36, there is no 36.
38.
38.
Yeah, 38.
This 87 minus 77. This is the square of this has to be used. Those of you noted down the algebra, let me see, let us discuss. This is a square is used here. The first term, this is A, B, and C. This first term square is already used here. It's subtracted. After that, we came here. 134 we got. Here, the twice of this is subtracted from here. We got B, the second term, we got by dividing this. 18. 126 and 126 and remaining was 8. We got it 87. From that, we subtracted this square of this, the second digit. Square of this second digit got 38. From this 38, what we do? When we divided this, we got the third digit. This 2. 2 and remaining 2 is there. This becomes 28. From that, we subtracted the this 7 and 2. 7 into 2 into 2. So it becomes 0. So this gives me that gave me 0. When we do this 0 and divided it by this 0, we got 0, completely 0, and the 0 and 0, 4, it becomes 4, and from that we subtracted the last term, this one. You are asking, she was asking that is this 87, 38. This 87 minus 49 is 38. Anybody wants to give another example?
See, that 38 is understood. How did you get 28? 28 is this 2 and 8.
2 and
Yes,
8, 28.
28.
And this
Okay.
other 28 is 7 into 2 into 2.
Okay. But then this 2 remainder, how did you get?
Where?
20
Oh,
for this 28,
it's
how did
38. 38 divided by 18.
38 divided by 18? Okay. Okay. Right. Right.
Shall I give one more, sir?
Yeah.
571.
571,
536.
536.
Yeah.
Oh.
7 if we'll take, and 7 square is 49. 8 we'll get the remainder. Drop
And
down
left,
1 from the top.
left,
becomes-
left to write something.
14.
Don't
square
forget to
will
write
do-
what in the left. That's always
14.
you are missing.
Sorry,
Ah,
49.
right.
Square of 7 we have to do. So
Ah.
49 we'll get in the left.
Hmm.
8 is a remainder. Drop down 1 from the top. It becomes 81. Then 49 means 1 time.
5 times. 81 by 14, isn't it? Gautam ji,
Yeah.
is it 81 by 14?
Yeah.
5 times, 14 5s are correct. 70. So we'll get 11 again. Yeah, 1 minute. This one. Again, drop down 5 from the top.
Huh.
It becomes 115.
Hmm.
Here we have to 5 square.
Yes, exactly. Good.
Okay, 5 square, 25. 90 we get balance. Hmm. 14, 6, 82. 14, 6 is 82. 84, sorry. 6 is the balance. Drop down 3 from the top. It becomes 63. 63. Then here 2 into 5 into 6, like that.
Yes.
2 into 5 into 6 means 60. To is it? Yeah, 60. Balance is 3 and 6. Yeah, I got it. And then 6 square, last one. Yeah. In the middle expression is 2 into 5 into 6 means 2 BC. It is like that.
2
2
BC,
BC.
yes, exactly.
Yeah, 2 BC. And we have to square the last one. So 6 is a 36 is a 0 balance. Yeah. We didn't get any
Remember.
2 zeros. We got only 1 0. Yeah. Yeah,
And
then
this
I got
becomes
it.
again is 36.
Yeah, it's 0.
And 36 we subtract square of this number.
Square, yeah.
6
Yeah.
into 6.
6 is a 30. Now I got it, sir. So in the middle expression is 2 BC. It is like
2
that.
BC. Huh?
Yeah.
So, If anyone else wants to try or he has a doubt, he can write, can raise their hand in the reactions so that you can unmute. Otherwise, Gautamji, you can go ahead.
Yeah. So this procedure is well understood. Rather, I think, so this square root is now well understood, isn't it?
Gautamji, I think in the last example, they want no talking about algebra and just doing the
Yeah.
without talking about algebra because they're worried about algebra. Just how we do the problem. The same thing was done, but then people, the moment you say BC, 2 BC, then they are gone. So, so just do an example. The same previous example you show them. Whatever you have done earlier, which is in the PPT, you just explain there. I think they'll follow it.
No, here I have written no.
Yeah. Just show them.
So this is see,
Durga Garikapati garu, I'll unmute you. You can.
so you read it. I mean, instead of doing, you just see the already it is in front of you. You see how it is done. Group digits from, and first step is group digits from right.
సార్ ఇది మీరు ఇచ్చిన ప్రాబ్లం చేయండి సార్. ఫిజికల్ గా చేసింది 2 చేశారు కదా లాస్ట్, ఏదో ఒకటి లాస్ట్ అండ్ లాస్ట్ బట్ వన్ physically you have done, no sir, that you kindly show. No,
I mean, either that or the one which is shown on the screen. I think
This also well, this also good.
no, I have done those 2 problems, that's why. So I got something wrong, so I want to check.
Right, okay. So he can't go back.
No, but you see, now whether my explanation in this thing is correct or not. See, it is clear or not. See, square root of 55 is 7, remains 6. Okay, put down the 7, double 14 is written left. Then 6 with 2 gives 62, and this when it divided by 14, it gives 4 down as a second digit of result, a Q quotient, and 6 remains. With 0, it gives 60. From that, we subtract square of this. Square of this 4. So it becomes 44. 44 is written 44 again by 14. It give us 3. And drop down, so you drop it down, and then 2 is written here. And 2 is remaining. It becomes 24. From this 24, you subtract 4 into 3, 2 into 4 into 3, 2 into 4 into 3. 2 into 4 into 3, it becomes 24 minus 24. It becomes 0. And 0 divided by 6 is, it puts 0 and put down
One more 0.
One more.
Got it?
So here this 0 divided by 6, how it came? 3 into.
Oh, no,
3 into 2.
not 0 divided by 60. It should be something else.
3 into 6 only, sir. 3 into 2
how this 6
is.
came, sir? How this 6 came, please?
3 into 2 is 6. 3 into 2.
3
You didn't write it separately.
If you put your arrow 3 and 2, then they will understand. Your cursor.
Oh.
If you show that 3 and 2 and 2.
And we finally get 0.9 and 3 square is subtracted. This thing.
Durga Garu, I hope you got it.
I'm trying to, sir.
Oh yeah, you have to practice. Then only, first of all, on this example, You
Yes.
could understand, isn't it?
Yes, I understood. That's why I did these two problems. But in the third calculation, it went wrong because
No
I am
worry.
getting 6 while they got 8. So I didn't know how to.
No, some subtraction problem will be there, nothing else. You do it again, you'll learn.
No, actually, so far we are always dividing by 14. Okay, 14, this 14. Now, what is the device of the twice of that? It's not 6, it will be 8. You are correct. You pointed out something was wrong. You correct it here. You correct it. Huh? I will correct it later. It should be 8. Twice of this number. So far, see, already in 2 places we have used twice of this 7. Twice of 7 we kept here. So, and we used it here as well as here. See, 2 places we have used. Now, where is this twice of this is used? Twice of this is used here. So this will be 8. Divided by 8. So normally at this level, we get 0. 0 only. So there is no as such no problem in that. But suppose we get something after decimal point, then we'll create problem. So better to know that this is divided by double of the second digit now. So this is double of the second digit, and we get 0 and 0, and with this 09, we get 09. And from that we subtract the third digit, square of third digit. Square of third digit. That means 9. So 9 minus 9 is 0. It's clear?
Okay, you can go forward.
Go forward, yes. So certain things have to discuss, like there is one this thing in the course, it is written remainder theorem. Remainder theorem. Some of you told that you do not understand much about the algebra, x square and so on. So it will be very difficult to do this thing at times. Let me give some other example. Many things in Vedic mathematics are actually with respect to the
Algebra.
algebra only. See, not only arithmetic, but Vedic mathematics is also good at algebra and to calculus. How many people have some background in calculus?
I don't think, not many.
Achha, I will I will use the white screen and do you something. So all of you know that if there is a figure, a triangle with sides A, B, and C, what is the relation with, right angle triangle? This angle is 90 degree, right angle. Now all of you know now this angle of this plus this is how much? First of all, what is the summation of angle? Suppose this is I've written this should be capital. Okay. Sides are written as capital. Small. Oh, small can also be written. Oh, okay, forget it. Right. A, B, and C. What is the
T is equal to root of A square plus B square.
I mean the relation between these two is A square plus B square is equal to C square.
Right.
Correct? And it is called
Pythagoras theorem.
Pythagoras theorem. What is the proof of that? What is the easiest proof you got to tell?
Could not get you.
Easiest proof is this. What I have seen actually. You make a square like this, and from that you do like you take A and B. This is A, this is B, this is again A, and this is B, A, B, A, B. And join these. And we call it C. The same thing is written in a different thing. We call it, we do not know the value of relation between A, B, and C. Now, by symmetry of the drawing, all these numbers are, all these triangles are have the same, they're all similar in same format, same everything. And therefore, this also becomes a 90 degree. This also this 90 degree, of course. This also from the symmetry of the figure, everything is, this also a square. Now, area of this smaller triangle is C square. There is no problem with that. Area of the larger, sorry, not triangle, area of the larger square, it's smaller square. Area of the larger square now is what? It is one side is A plus B, so A plus B whole square.
Yes.
Which is equal to A square plus B square. I did it in this form. Sometimes it is A square plus 2AB plus B square. Here, right? A square plus B square plus 2AB. Now, each of this triangle, this is a small square. Small square. You can write in full form. My writing is not very good here. And this is the large square, bigger square, large square. And triangles. All the 4 triangles are similar, and they all have equal number of things. The triangle area of the triangle is how much?
Half AB.
Somebody may tell?
Half AB.
Exactly. Half AB. Half into base into height. It's called.
Right.
Now there are 4 such triangles.
Into 4.
What is that? 4 into that half AB.
Right.
What is that? Is equal to
2AB.
2AB. So it becomes transparent like anything, that the larger square is actually a sum of these smaller square plus this, all the four triangles together, which is 2AB. That means larger square is A plus B whole square. That means it is A square plus B square plus 2AB. And this is the larger square. This is smaller square is C square plus these four triangles, which is 2AB again.
Yeah.
From that, what we get?
A square plus B square.
Exactly. So my A square plus B square becomes C square. Did you find a easier than this one, the proof of the Pythagoras theorem?
Right. I think others should say, I have been saying, but then others.
Please tell me what anywhere any confusion.
Anyone has any problem, please raise your hand. Raise your hand. The reaction box, raise your hand in case you have a doubt.
This also, Vedic mathematics also deals with so many geometrical things I find in the book. There are other books also where.
Here this half AB, can you please explain once?
This is the area of a triangle. Area of one triangle is half AB. This particular triangle, area of this triangle, where it is right angle triangle, and one side is A, one side is B, is half AB. Half into base into height, it is called. Half into base into height. Even for any triangle like this. So there is a height is there. So this is, suppose base is A and height is H. Whatever be that, this may be BC, doesn't matter. So it is half into A into H. Half AH. This is the triangle area formula.
It's a formula.
No.
There is nothing. It's a formula.
It can be proved also. Then
Right,
we are supposed to prove it.
Okay, I think next we can move forward. We are 15 minutes.
Because see, in case of right angle triangle, it is very easy. For a this quadrilateral, I mean rectangle, general rectangle, not square. If it, one side is A, one side is B, area is AB, isn't it? Everybody knows it. Area is length into breadth after all. And triangle, like right angle triangle, is a half of that. So half AB. It is a proof. In case of right angle triangle, it can be proved. So this is the proof of the half AB. This is half AB, this is another half. Totally different. Okay. So here each of them will become half AB. So the four such is there, twice AB. So these actually a lot of geometrical things are also there. So I shall Pythagoras theorem. I can discuss a little calculus also. Should we discuss a little calculus about calculus?
I think they'll run away.
Maybe tomorrow we'll do something.
Right.
Some introduce some calculus. Today, if there is any question from anywhere in the part.
I think that is better. I mean, we'll brush up whatever has been done till now, yesterday and today. If they have doubts, we can clear them. So now I think I'll unmute all, I think. Yes, all are unmuted now. So you can raise your hand or talk one by one. Yes, please go ahead with calculation. Okay, that is Praveen Kothari says you can go ahead with calculus, but then we don't know about others. They are all general maths people and commerce graduates and many like me who have forgotten maths. Okay, any doubts? Please take example of 10201. K.M. Rao says, and explain the square root.
What is that?
10201.
Sir, I have done for 10201. Can I show?
Yeah, sure. On the screen you show?
Yeah.
Or you can just keep saying as it will be written.
Is it seen, sir?
Gautamji?
I have to stop this sharing, no?
Right. I mean, you can wipe up this white screen and make it white.
Oh. 10.
Right.
20.
This is what is the problem. Somebody trying making noise. Please. Then I'll have to mute everyone.
Cooker nice.
Somebody's background noise is coming, please.
You did like that? Yeah, in the older method, you have, I do not see properly. Square root.
Please try to understand background noise is coming. If individually you have to mute yourself. Otherwise it is creating a lot of noise.
Babu, you ask them to raise their hands rather than
people are not doing it.
Yeah, you ask them to raise their hand instead of unmuting all. This is the noise we are getting, disturbing
Yes,
noise.
I muted all. Right now, Gautamji, you can unmute yourself and keep talking. Gautamji, I have muted you. You can unmute yourself and talk.
Babu garu, when this iPhone has raised his hand, you just open it and you just ask the name first. Because for my attendance and all, it's become a problem. This
Right,
iPhone, I chatted also.
Right, I know.
Now, since he has raised his hand, you just ask first the name, the PRN number.
Yeah, Mr. iPhone. First
I have
of all,
chatted also. I have sent in chat also your name and PRN, but no response.
Right, before we go ahead with the class, iPhone, please try to put your name. What is your name? Please speak out.
Some names are there, like Ram Mohan Namile Garu. It is 2208 is number. He puts it as 2028. Let him note down because I am able to do it. Even with Satyavati ma'am, I am doing it 2140. Like that, some names, Chakravarti Garu 2292.
Yeah.
Venkatramana Namile Garu, it is 23. Venkatramana Garu, it is 2.
I think after class
We have to tell them because 10 people, they always miss out this one. Okay, anyway, please carry on. I just wanted to remind you about iPhone.
Right. Yeah. Okay, now 10201, Gautamji, you can go ahead.
Everything you get 0 here. Drop down 0 here. Then we got 0. Then we get 0 here. Oh, sorry, not 0 here. This is 0. Here we get 0. This becomes 2. Divided by 2, so it becomes 1 and 0 here. From that we subtract again 0 is equal to 0. From 0 and this from this is 0, 1. This 1 minus 1 is again 0. Result is 1, 1, 0, 1.
So whoever asked this question, hope it is clear. K.M. Rao garu.
One 0, 2, 0, 1. If we from the right, if we group into 2, 2, we get finally 1. We get 1. We start with that 1, and square root of 1 is 1. We write 2, double of that in the left. Next is what we did. We subtract this 1 from 1, it becomes totally 0. 0 right here, and as a this 0 if we write this one, and we get 0. 0 divided by 2 is we drop down 0 and both becomes 0. Drop down 0 is the second digit of my result, and 0, this 0 and 2 becomes 2. When you divide it by 2, it becomes result is 1.
1 minus 1.
And 1 minus 1 is 0 here, and whole thing is 0. And then when we subtract with 0 into 1, again it becomes 0. 0 minus 0, again 0. This 0 comes here. And with this 0, 1, we get 0, 1. And when we subtract with square of this 1, it becomes again 0. So this 0 is coming, that division of by again 0 in division by this one. Otherwise, it will be division by 0. So not the division. Here you get 0, 1, and 1 minus 1 is 0.
Okay, I think that's clear. And any other doubts? You raise your hand, otherwise it is not possible to unmute all. Raise your hand so that I can individually unmute, and then you can raise your doubt. Okay? We have only 5 minutes to go.
Babu garu, Tirumalaya garu has raised first, and then M. Srinivas Rao garu. You both,
But why is
you
it not seen here? Okay, just a minute. Right, Tirumalaya garu. Right. Okay. Tirumalaya garu, you can raise your.
Sir, Sarvebhyo Namaskaraha. Sir,
Namaskar.
just I wanted to know whether you are doing this problems as per that ax square plus bx plus c square with that result, or you are adopting some other procedure. Just I wanted to know, sir.
Background, this is that procedure is there. This one you are talking of, this one.
Yeah. If that is there, what is A, what is X, you must just specifically, if you show it, everybody will can understand better.
But what is the meaning of this X?
No, that value you must know. This is the algebraic formula, you know.
Yeah.
That is the result of the algebraic formula. Last ax4 plus 2abx cube plus b square plus 2ac x square plus 2bc x plus c square. So in this numbers you have given, what is that a, what is that x, we should know. Otherwise, we cannot solve this.
Oh, yeah. Here actually, this is the general expression. Here x is equal to 10.
Sir?
X is equal to 10. X is equal to 10. That's all.
AX is equal to 10.
Exactly. X is, sorry,
Is
X
equal
is
to
equal to
10.
10.
Yeah. If we
And-
incorporate it, we will get the results. That is the problem we are unable to understand.
Yeah, we will be giving, suppose we will be given a square, where square root must be this one. Square root is actually three digit. Suppose it is that we did 825 or something like that. So A is 8, B is 2, and C is 5. So the number is 8 into 100, this x square is 100, 8 into 100 plus B into 10 plus 5. That means 825. This we do not know this. We do not know ABC. Okay.
Yeah.
We have to find out ABC. How you will find out? We had been given this number. It is a mixed up number. It is a total number. It is mixed up. It is totally mixed up with carry and everything. From that, we are filtering out the result. So whenever we say that nearest to that is something, let me see, I will exactly tell you that what 825 square is, somebody tells you, please. 800, we did already. 825 square is how much? 69 something, no?
Oh.
68 or 69.
No, 825 cannot be 69. Acha,
Square of that.
square of that. Again, it should be 5, isn't it?
5 digit. 6 digit. Anyway, it is started with 68. So
Yeah.
what we did is nearest to the square of that
680, 625.
686.
6806
625. Yeah.
680 625. Yes.
625.
So we did like that. Now, first of all, we have to know that nearest to that. So this one is mixed. A square x to the power 4 is there. You have to first find out the first term. So this is actually, we go to nearest to that. So from that we get A. Now, from that, we get 16 we divided, and from that we get B. As soon as there is remaining 4, so it becomes 40. From that, when you divide it by 8, we got 32, this one, 2 and 32. The 2 we got from that. From here, you got 8. We wrote 16. And here, as soon as you divide this 40 with 16, that means we are dividing by 2A, and we are getting B. And B is got 2, and then the
So
remainder
how
is
we will get this 16, sir?
double of that. The twice A.
4
Yeah.
4 into 4. Is it 4 into 4 or double of 8?
Not 4 into 4. It is double of 8.
Yeah.
A is 8. This is found out, no?
Yeah.
A is already found out by square root, making square root
Yes,
of
yes.
68. So double of that is known now. Double of A 16. Now from we did 16, we divide this one 30. So we got 2. So this is my B. Then after that, what is remaining is 86, and from that 86. Now we come to this one. I have to find out C. What is C? I don't know C. From that, therefore, we are subtracting the B square. What is B square? Is 2 into 2 is 4. We are getting 82. Again, we are dividing this by 16. B square we have eliminated already. The B twice A we are subtracting. As soon as we do that, it was 82. We got 5. And remaining 2 is there. So immediately got this way we got 2. And others are for matching whether everything is correct or not. Again, we do that, we subtract and so on. But by these 3 steps, we got these 3 results. ABC A, B, C didn't know earlier that A is 8, B is 2, and C is 5. From this, we step by step, we got first by square root, first by making square root, second by dividing it, second by subtracting and then dividing. We got all these digits. Okay, clear?
Okay.
Any doubt?
Okay,
How
anyone
you are
else?
getting? So therefore, this particular expression, this particular expression explains my steps. These three
Right.
steps. After that, we are matching that everything is there is no remainder is perfect square. These two are for matching purpose. This initial 3 steps are for evaluation purpose.
Okay, thank you, sir.
Okay, I think
Tomorrow I'll do remainder theorem. There will be again some expression. I'll maybe that I can give an just a small introduction. Like suppose there is a big thing is there, big equation is there. Suppose, okay.
Gautam ji, it's 8 o'clock. Can we?
Yeah.
Babu garu, iPhone, you don't forget. Who is iPhone?
Hi. Right.
Is it? Yes, I think tomorrow I'll do this remainder theorem. Only thing that if big equation, suppose one big equation is there, x to the power 5, and we do not know b into x to the power 4 and so on. But whether there is a small thing or say x minus 2 is factor or not. So x minus 2 is 0. If x minus 2 is 0, if it is this remainder theorem says that you replace all this pi x by 2 and see whether it is matching or not. So that whatever comes there, it will be remainder. Something like that. I mean, I'll explain it tomorrow again.
Right. I think we'll explain tomorrow. And then at this moment, thank Gautam ji for his patiently answering the questions and explaining the square roots, how to solve it, the big numbers. Thank you very much, Gautam ji. Now I request Surya Prakash Garu for doing the Pradhana.
Yes, sir. Sri Gurubhyo Namaha. Swasti prajabhyah paripalayanta nyayena margena mahim mahisah gobrahmanebhyas swamastu nityam loka samasta sukhino bhavantu kale varshatu parjanyah prithvi sasya salini desoyam kshobarahito brahmanas santu nirbhayah aputrah putrinas santu पुत्रेण संतु पौत्रिणः अदनाः सदनाः सन्तु जीवन्तु शरदां शतम् सर्वे भवन्तु सुखिनः सर्वे सन्तु निरामयाः सर्वे भद्राणि पश्यन्तु मा कश्चित् दुःखभाग् भवेत् असतो मा सद्गमय तमसो मा ज्योतिर्गमय मृत्योर्मा अमृतङ्गमय ओम शांति शांति शांतिः पूर्णमदः पूर्णमिदं पूर्णात् पूर्णमुदच्यते पूर्णस्य पूर्णमादाय पूर्णमेवावशिष्यते ओम शांति शांति शांतिः सर्वेभ्यः नमस्कारः धन्यवादः
Thank you, Surya Prakash Garu. Dhanyawadalu. Now we stand up for this national anthem. Janagana mana adhinayaka jaya he Bharat bhagya vidhata Punjab Sindhu Gujarat Maratha Dravida Utkala Banga Vindhya Himachala Yamuna Ganga Uchala Jaladhi Taranga तव शुभ नामे जागे, तव शुभ आशीष मांगे, गाहे तव जय गाथा। जन गण मंगलदायक जय हे भारत भाग्य विधाता। जय हे जय हे जय हे जय 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 हे। जय हिंद, जय हिंद। I'll stop recording and then we'll.
Babu garu just ask.